What's up guys, welcome back to the channel. In this particular video I will explain the problem delete nodes having greater value on right. This particular problem is again based on the same concept that we have learned yesterday guys, so make sure you stay tuned till the end of the video because this video is going to be really interesting. So let me start with the problem statement. It says that you are given a single linked list. You have to remove all the nodes in the list which have any node on their right whose value is greater. Okay, and now not just immediate right but in the entire list on the right. Okay, we are given a linked list as an example guys. Let me explain using this example. We are given this particular list. Our task is to remove all those nodes which have greater value on right. For example, see this node 12 guys, it has a greater value on the right, so this node should be deleted. After this, see this node 10, this node 10 should be deleted because it has a greater value on the right. After this we have a node 5 which have greater value on the right. Similarly, this node 2 has greater value on the right. So all these nodes should be deleted, and when we delete these nodes, then we will have remaining nodes as 15, 11, 6 and 3. So all these nodes are going to be the part of answer. So this particular list is going to be the output you can see here. Now guys, I hope you have understood the problem well. Let me explain using one more example guys. So let's say I have a list which contains value 12, then 11, then 13. For this list guys, the output is going to be a single node 13. Why? Because see, this 12 contains a greater value on the right. It says that not just immediate right but in the entire list on the right, if you have a greater value then delete the node. I will delete this node. Then for this 11 again I have a greater value on the right, so I will delete this as well. I'll be left with this 13 only. So this particular single node is going to be the output. Now guys, let's talk about the solution. Okay, so I have written the same example as given in the problem statement guys, and this particular problem is going to be solved by the same concept that I have explained you yesterday guys. But before that we are going to make three important observations which are going to help us to find the approach that we need to follow, right? So let me write three observations here. Starting with the first observation, so see guys, according to the problem we need to delete all the nodes which have greater value on the right, because you can see that for this 12 we have greater value on the right, and for this 10 we have greater value on the right, then for this 5 we have greater value on the right, and for this 2 we have greater value on the right. So after this we are going to write the remaining nodes in the answer. So what are the remaining nodes? The remaining nodes are let me change the color guys. So I have 15, then I have 11, then I have 6, and then I have 3, and this particular list is going to be the answer, right? So the first observation says that we have to think of the problem in another way guys. See, instead of deleting these nodes, I can pick all the nodes that will not get deleted, right? So what are the nodes that will not get deleted? We have 15, then we have 11, then we have 6, then we have 3, right? So this is the first observation. It says that pick all nodes, pick all nodes which which will not get deleted, right? Which will not get deleted. This is the first observation that we have. After this guys, talking about the second observation, so see, this is the answer list that we have, right? And this answer list is 15, then we have 11 which is smaller than 15, then we have 6 which is smaller than 11, and then we have 3 which is smaller than 6, right? So this is following descending order of elements guys. And is there any guarantee that for every particular list the answer will be in descending order? Yes guys, there is a guarantee. Why I am saying that? Because see, I'm deleting all the nodes which have greater value on the right? So I'll be left with only those nodes which have smaller value on the right, isn't it? So for this 5, I know every value on the right is going to be smaller, right? For this 11, every value on the right is smaller. Then for this 6, every value on the right is smaller. So this is nothing but descending order of elements. So the second observation says that answer list answer list is always going to follow descending order of elements guys. This is the second observation that we have. Talking about the third and the last observation, so this is very interesting guys. Third observation says that we are this last element is always going to be the part of answer guys. Why I am saying that the last element is always going to be the part of the answer? Because see, for every element, we have to delete those nodes which have greater value on the right. But for the last element in any list, we are not having any element on the right. So guys, this is never going to be deleted, and this will be the remaining element for every given list. So we are going to include it in the answer, right? So last element, let me write the third observation. Last element, last element is always going to be the part of the answer, right? Going to be the part of answer. So these are the three observation, and now guys, we are going to use these three observation in order to find the answer. Let's see how we can use these three observation. So first of all, I will write the same example below so that I don't have to scroll again and again. So what is the example that we have? We have 12, then 15, then we have 10, then we have 11, after this 5, 6, 2 and 3, right? Now guys, as I scroll down, so I will not need to scroll again and again. Now see, these three observations are going to help us to find the approach, guys. The first observation says that the last element is always going to be the part of the answer list, right? So just blindly include last element in the answer. After this, we are going to traverse from right to left, guys, because we have included this element first in the answer. After this, the question is which is the second element to include. So see, answer list is following the descending order, right? So this means that the next element should be greater than these three so that I can have descending order from left to right? So I will pick the element which is greater than 3. What is the element? The element is 6. So I will simply pick 6 as the second element. After this, I will again move to the right direction, guys, and after this I will pick okay, I have one redundant element. Let me remove this, guys, so that I can improve this. I have 10 here, right? And the third element that I will include is this particular 11. Why 11? Because 11 is something which is greater than 6, right? I have to maintain this particular condition as well. The answer list should be in descending order. So the third element that we have is 11, guys. After this, we are going to move again, and then the fourth element that we have is 15. So this is how I can maintain the descending order of element, and then we have simple answer list. So this is the answer list, guys, because for this, after this 15, there is no any element which is greater than 15, so I can't pick any element, even not this 12, because 12 is smaller than 15, right? So guys, this is how we are going to use this particular observation in order to find the answer. But there is a problem. While explaining the approach, I am moving from right to left, but guys, for a singly linked list, there is no any way to move from right to left. So how to move from right to left, guys? We are simply going to reverse this particular list so that we can easily traverse from right to left, because when we reverse this particular list, then we will have 3 first, then 2, then 6, then 5, then 11, after this 10, and then 15, then 12, right? Now it has become easier to traverse the list from left to right because we have a single linked list. So I can simply start from this. I will have a head pointer here, right? And guys, we are simply going to move this particular pointer to get the answer. Now I am going to write the pseudocode that we need to follow in order to get the answer. Let me write the pseudocode, guys. So first task, let me draw a line here, guys, and first task is to reverse the list. So let's say in the function we are given a argument head, right? So we are going to reverse the head, and we are going to store it in a reverse list variable. So this is going to store the reverse of head. For now, guys, you can assume that this function works somehow, because I will definitely talk about how the function works, how we reverse a linked list. But for now, I'm interested in approach, guys. So first I will explain the approach, and after this I will explain how this reverse function work. So first step is to reverse the head. After this I will have a reverse pointer. So this is a reverse pointer, guys. This is going to point to every particular element in this particular list. So what I'll do is I'll simply start traversing the list. I will say that okay, while my reverse is not equal to null, I have to move reverse next, right? So I'll say that reverse equals to reverse dot next. This is what I will do. Okay, now before I move my next reverse pointer, before I move my reverse pointer from this 3 to this 2, I have to include a element to the answer, right? And before that I have to check whether I can include that particular element to the answer list or not. So I'm going to have answer list as well. So let me write answer list here. This is just to represent you guys, otherwise I'm going to initialize my answer list here. So answer list, now this is the same concept that I have explained to you yesterday. See, answer list is initially equal to dummy node, guys. Why we make a dummy node, I will explain you. So before that, let me make a answer pointer as well. So I have answer list and it is initially storing -1, guys, and we need a pointer, answer pointer, and this particular pointer is going to point to last element of answer list every time, right? So I have a answer pointer. Let me write pointer. This is equal to answer initially, right? Because answer is pointing to this particular head node. Okay, now guys, see why we initialize answer with -1. So there is a reason, guys. I will explain you when I write this particular condition. So before that, how we are going to add element, this is the main question. See, when I move from this particular 3, guys, so I will move to the next node which is greater than this 3, right? So that I can maintain the order, I can maintain the descending order of elements. So of course I'm traversing the like list in reverse, so I have to maintain ascending order now, right? So guys, now I will traverse the list, and for any particular element I will append a element which is greater than this particular element, right? Let's say I have a node 6 here, so I will append this 11 to the end of 6 because this 11 is greater, right? So I have to maintain the ascending order. So I'll start with this 3. Okay, why I'm starting with 3? Even let me write a condition here. If my pointer dot data, if my pointer data, because pointer data is the data which is present at the last element of answer list, right? So pointer data, if this data is smaller than reverse data, guys, reverse data. Why I'm writing this condition? So that I can maintain this particular condition which is ascending order of elements. So if this is the condition, then I will append the current node value to the answer list. So how I can append? I have answer pointer, so I will say that okay, now my answer pointer dot next is equal to reverse. Reverse is currently pointing to this particular node, right? So now my pointer next will be pointing to 3, right? So now I have 3 here, and I will do pointer equal to pointer dot next. Why I am doing this, guys? Because now this is not my last element. My last element is this 3, right? So my pointer is always going to move when I add an element, so that I can point to last element each time. So guys, this is all we need to do. After this, my reverse will move to next place here, and you can see that for this is not something which is greater than 3, right? So I will move my pointer again, and now I have 6, guys, and this 6 is greater than this 3, so this condition is true, and I will simply add 6 here, and now my pointer will point to this particular place, right? After this, I will come to this 5. 5 is again, this condition is not true because 5 is not greater than 6. After this, I will come here, 11 is greater than 6, so I will add 11 here, and guys, now my pointer will move and pointer will point to the last element, so pointer will come here. After this, I will come to this element. This is not greater, so I will come to this element, and I will simply append 15 here, guys, and now my pointer will be pointing to this particular element. So this is how I can form my answer list. Once this particular loop is done, I am done traversing the list, so I can simply do one thing. I can write my pointer dot next equal to null, because in a singly linked list, answer list is basically a singly linked list, so my last pointer should point to null, right? So this is how I can get my answer. Now you can see that we have extra -1 here, right? So guys, what I will do is I will do answer dot next, and this will give me a list starting from this point to the last point, right? And after this, I will reverse this particular list so that I can get my answer, because I was traversing the reverse of the given list. So when I reverse this particular list, I will get my answer. So at last, we just need to return reverse of reverse of answer dot next. Guys, this is the approach that we are going to follow. See, answer dot next, because I want to remove this particular -1, and then I just need to reverse this list. I will have 15, then 11, then 6, then 3. This is how I can get my answer, guys. Now I hope it's clear to you. So this is the approach that we are going to follow, guys. I have written the pseudocode as well, right? Now the question is how we reverse a linked list, right? Because I have not talked about this particular thing, guys. So let me explain how we reverse a list. Let me write here reverse a linked list, right? If you are someone who already know how we reverse a linked list, so guys, you can directly skip to the code part where I have shown the code in C++, Java, and Python, right? But for those who don't know, I'm going to explain for those guys. Okay, now let me take an example. So I have 1, then 2, then 3, then 4, then 5. This is the list that we have, guys. So how we are going to reverse it? See, for every list we have a pointer, which is our head pointer, right? So this is the pointer that we are going to move, and we are going to change the pointer. For example, for this one, 1 dot next is equal to 2, right? So I will make head dot next equal to previous element. Initially previous is equal to null. After this I will move here, then previous will be pointing to this one, right? And when I make this 2 dot next equal to previous, so this 2 will be pointing to this particular element 1, right? And this way I'm reversing the link. So see, let me explain the whole dry run, how actually it works, guys. So uh, initially I have my previous, which is equal to null, right? My previous is equal to null. So I'm currently at this position. I will say that, okay, whatever is my head dot next equal to previous. So I will do head dot next equals to previous, right? And what this will do is it will make this particular node next equal to previous, which is initially equal to null, right? After this I will move my head here, and my previous will come here. So I will make my previous equals to head after I do this step, right? So I will make my previous equals to head, and head equals to next, right? What is this next? This next basically comes from whatever I have stored before I perform these operations. So I will have a next variable which is equal to head dot next, right? So guys, this is what I can do, and my next is initially equal to null. Okay, after this my head will come here, and now what I'll do is I'll perform this particular step where I have done head dot next equal to previous. So previous is this element, and now my 2 dot next is equal to this particular element 1, right? After this I will come here, head will come here, and then again I will do this step. So this head dot next will become equal to this 2, because now this 2 is previous, right? After this I will come here, and previous will come here. So I will again do head dot next equal to previous. So this is how, guys, we can reverse the list. At last I will do for this, and now you can see that I have first 5, then 4, then 3, then 2, then 1. This is how we reverse the list. So I will simply run this loop while my head is not equal to null, right? This is what I can do in order to reverse the list. And at last my head was here, right? So head will move here, head will become null, and previous will be pointing here. So at last I just need to return previous, because previous is storing the head of the reverse list. So this is how, guys, I can simply reverse a list. Now I hope you have understood how reverse list also works. So let me show you the code, guys. Okay, so here is the code. You can see that this is the reverse function in C++, guys. This is how we reverse a list. After this, this is the main logic that we have. See, first we reverse the given list. This is the head of the given list, right? First we reverse the given list, then we make a answer and answer pointer. Answer pointer basically points to the last element of the answer. Then we run this particular loop where for each value I check this particular condition, so that I can maintain the ascending order for the reverse list, right? So that descending order is automatically maintained for the answer list that we have, because we reverse the answer, guys. And this is how, this is the Python code that we have. And at last we have Java code as well. So this is how we are going to solve the problem. Talking about the time complexity, so the time complexity is O of n, guys, because O of n for this and O of n for the main logic that we have, main approach. So O of n is the time complexity, and the space complexity is O of 1, guys. Why O of 1? Because we are not creating any new node, guys. Even you can see here, we are not creating any new node, we are just creating new node for this -1. So for one node the complexity is going to remain same, which is O of 1. And for this we are just manipulating the pointer. You can see here we are not creating any new node, right? How we determine whether we are creating new node or not? So whenever we create a new node, guys, so we write a syntax like this: new node, then we write whatever value we want to make, right? This is how you can determine whether we are creating any new node or not. So for this we are just manipulating the pointers, guys. So that's why the space complexity is O of 1 and time complexity is O of n. This is all about this video, guys. Thank you.